Okay, grade 8 for my last example. So let's graph this to equate this system of equations. Okay, x minus 3y equals 3, 2x minus 6y equals 6. If you notice, this is, kind of somewhat related to this equation. I will not tell you how, okay, or why. Anyway, let's first write it in slope-intercept form. Negative 3y minus negative x plus 3, and then simplifying, y equals negative 3 on both sides, so you have positive 1/3 x, negative 3, negative 3, negative 3. So positive 1/3 x, however, your y-intercept is negative. Positive divided by negative will give you negative. The m here is 1/3, the b is negative 1. This one, negative 6y. Negative 6y equals negative 2x plus 6. Divide by negative 6 both sides. So y is now positive 1/3 x Let me write it again. Y equals positive 1/3 x minus 1. So identifying the m is 1/3 also, and the b is also negative 1. Right? So what have you noticed? After simplifying, you end up with the same equations. Right? They are the same. And of course, since they are the same, exactly the same, the m and the b of each of these, the m here is equal to the m here, the b here is equal to the b here. So without graphing, automatically you can tell that your system is consistent dependent. Okay, since it's consistent and dependent, how many solutions again? Infinitely many, correct. So what is the graph of a consistent but dependent equations? Okay? So let's graph. So from negative 1, rise 1 and run 3, because your slope is 1/3. So connect the 2 points. Of course, pardon me, I can't use a ruler because I'm holding a phone. And label it. X minus 3y equals 3. Your other equation, I don't have any other color. You can use a different color if you have colored pens. So I don't have a blue anymore. So I still have here and negative 1, rise 1, run 3, still end up with the same equation because they are coinciding. I will label my other equation here. 2x minus 6y equals 6. I'll just show two lines overlapping. Okay, do not overlap your arrows. How would I know that they are overlapping? I see the arrows have different locations. So there you go. So now let's recap. Okay, so the solution of a system of linear equations in two variables whose slopes are not the same, the solution is only one, uniquely one solution, one ordered pair, which if we substitute these two values for x and y in both of the equations will give you a true equation, meaning the left side of the equation is equal to the right side. Okay? The left side of this equation will be equal to the right side. It should satisfy both equations, not just one equation, for it to be considered a solution to the equations. Okay? But if the slopes of your equations are the same, once the slopes are not the same, automatic you can say they are intersecting. But if the slopes of the equations are the same, check the b or the y-intercept. If the y-intercept are not the same, just like in our previous example, then the system of equation is considered inconsistent, meaning they are not intersecting, and meaning there is no solution set because the lines are parallel. Without graphing, you can tell that the solution is none, because there is no solution because your lines will be parallel just by looking at the M and the B. But if your M and the B are both the same, the M of the first equation is equal to the M of the second equation, or the slopes, and the y-intercept, or the B of the first is equal to the B, or the y-intercept of the second equation, then we can say that they are consistent. They are consistent but dependent, meaning they are coinciding. The lines are coinciding. The solution is infinitely many. All the points here, the ordered pair that you can get. You see, locate one point, locate another, check, substitute it to your equations, and they will give you, okay, they will give you, what do you call this? Zero, or, so they will give you a true equation, okay? So, dependent, all right, is a solution to the equation. All right, next, I think that's all. So, if you cannot, what do you call this? If you cannot understand, just pause and review. All right.